All right, so power is the rate at which work is done. So if you have, for example, a more powerful engine in your car, you can climb hills faster, right? You can do more work in a shorter amount of time, right? You can speed the car up, et cetera, et cetera. If your elevator has a more powerful motor, it can lift the elevator farther in the same amount of time. Okay, that's the basic idea. The formula is that it's work divided by time. They also give you force times velocity. This is what it looks like in the data packets. So way back in section 8, 8.1, the first formula is this. And then in section 2, they've got this strange formula here. These guys are the same, right? Because remember, power is work over time. Work is force times distance over time. Distance over time is just velocity. So force times velocity is also power. Okay. Let's just look at some simple problems here. Well, a person does 48 joules of work in 6 seconds. So let's see, power is work divided by time. So 48 joules in 6 seconds is 8 joules per second, right? Okay. You can also say, or 8 watts, right? Watt is the unit of power. Watt is the unit of power. A watt is the unit of power, right? 8 capital W, right? And this is the famous physicist Watt, not James Watt, the Secretary of the Interior under Ronald Reagan. I believe he believed the world was going to end soon and we should use up all the natural resources. But anyway, all right. So let's look at the second problem here. How much energy does a 75 watt light bulb consume in a minute? Okay, so power is work divided by time. So therefore work, which is, by the way, the energy, right? Okay, work is power times time, right? So that is 75 watts times 60 seconds. We must multiply 60 by, let's see, what is that? That is going to be 4,200 plus 300. That's going to be 4,500, right? We can do that in our heads. We don't need a calculator. All right. And then let's look at the last question, which is a little bit tricky, right? Because we have to figure out, this is horsepower. I actually had that 23 window van you saw on the slideshow. Is 30 horsepower, right? Pedal to the metal, it would go, honest to God, almost 55 or 60 miles an hour. But anyway, so the first step is to figure out what that is in watts. So 30 horsepower times, that's a P, times 745.7, and that is watts per horsepower. What is that? Let's figure that out. 30 times 745.7. Whoa, it's not going to like that. I get 22,371, 22,371 watts, or 22.37 kilowatts, right? It would also be 0.371 kilowatts. That's a decimal point there. That's a comma. All right. So now we've got the power, and we're going to use power as force times velocity, right? Okay, so 22,371 watts, 71 watts is equal to, let's see, the force, which we don't know, times the velocity, times 25 meters per second. All right, we can do this. All right, so 20, that divided by 25, I guess is what we do. 894.84 newtons, all right? That's our force. And then how is a watt divided by a meter per second? How many newtons? I guess this is, watt is a joule per second, which is a newton, second, which is a newton meter per second. And if you divide this by meters per second, you get newtons. All right.